Okay, so for today, our discussion is about introduction to function. Okay, so what are our learning targets for today? Okay, so number one, define functions and relations. Number two, differentiate between function and relation. And also, we're going to use the horizontal and vertical line test in the graph to identify if the given graph is a function or not. And also, if it is a function, we can identify whether it is a one-to-one function or not. Number three, determine the domain and range of the function. Number four, evaluate functions. Number five, perform addition, subtraction, and multiplication and division of functions. And then number six, perform composition of functions. Okay, so before we have the formal definition of the relation and function, we need to recall the idea of the Cartesian product. Okay, we need to recall the idea of the Cartesian product. Wherein, we let A and B be two sets, and the Cartesian product of A and B is the set of the Cartesian product of A and B. So given that we have this ordered pair of A comma B, wherein A, small letter A is an element of the set A and B is an element of set B. For instance, given that we have here set A be equal to the elements 2 and 4, and then set B elements are 1, 3, and 5, let's have the Cartesian product of A and B. So the Cartesian product of A and B here are the following ordered pairs. So we have here 2, comma 1, 2, comma 3, 2, comma 5, 4, comma 1, 4, comma 3, and 4, comma 5. And also, let's try to identify the Cartesian product of B and A. Okay, the Cartesian product of B and A are the ordered pairs 1, comma 2, 1, comma 4, 3, comma 2, 3, comma 4, 5, comma 2, and 5, comma 4. Okay, so please take note that the Cartesian product of A and B and A are distinct, meaning the order in which the sets appear is very significant. Okay, so please take note of that. Now, using the concept of the Cartesian product, let's try to define the relation and function. Okay, so first off, let's try to define relation. So in relation, it's actually in practical in our daily lives, we can relate this as people are related to each other, uh, such as our parents and the children, the teacher and the students, the employers and the employees, and so on. When it comes to the businesses, with the quantity of the product and its cost, the amount paid that is related to the number of or the quantity that you have bought. So with that, actually, we have the concept of the relation. And also, when it comes to the numbers, we have this as our formal definition. So let's use the concept of the Cartesian product. Let A and B be two sets. Okay, so a relation R from A to B is a subset of the Cartesian product of A and B. And also, a relation R on A is a subset of the Cartesian of product of A and A. So take note that we can have this notation. Okay, we can have this notation or this one, and we can read that as A has relation R to B. Okay, A has a relation R to B. Okay, so if it is not, okay, we can denote by this. Okay, if it's not, we can denote it by this. Okay, so let's have an example. Okay, let's have an example. So given this set A and B, Given that we have your set A and B, so set A 1, 3, 5, and then set B, we have your BTS. Okay, we have your BTS. B as elements B, T, and S. And we have here the relation R. So we have here the ordered pairs 1 comma B, 3 comma T, 5 comma S, and then 1 comma T. Okay, so in this case, as we observe, these are the Cartesian product. Okay, the subs we can say that R is a subset, okay, of the Cartesian product of A and B. Okay, so as you observe here, we have 1, then B, we have 3 and T, we have 5 and S, we have 1 and T. Okay, so with that, R is a relation from A to B. Okay, in addition, we can say that we have year 1 as has a relation R to B. Same with this. 3 has a relation R to T, and so on. Okay, and so on. Okay, so let's have another example. Okay, so we have here R, given that we have an ordered pair x comma y, such that x and y is an element of R, wherein x should be less than or equal to y. Okay, x should be less than or equal to y. Another example, let A is equal to set of PLB students and B be the set of PLB faculty members. Okay, so in this case, we can say that A has a relation of R to B, or A is a student of B. For instance, you, as my student in college and advanced algebra. Okay, so let's say Irvin. Irvin is a student of Sir Justine Asuncion. Okay, Maxine. Maxine is a student of Sir Justine Asuncion. Marie Chris is a student of Sir Justine and Asuncion, and so on. All of you. Okay, you can put your name to that and then my name to B. Okay, and your other professors. Okay, so relation can be expressed in arrow diagram. It could be one-to-many correspondence. It could be one-to-one correspondence. It could be many-to-one correspondence and many-to-many correspondence. So here in one-to-many correspondence, so as you observe, one element of which is 4 is connected to the elements of set B. We have 2 and 3. Okay, so we have 4 comma 2 and then 4 comma 3 if we express that into the ordered pairs. And then we have your one-to-one correspondence wherein one element it only corresponds to one element to another set. So we have your 1, 2, 2, 3, and then we have 3, 4. And then for many to one correspondence. Okay, here in many to one correspondence, so there are 3. Okay, so 2 or more that is connected to one element of the other set. So we have here 7, 3, 8, 3, 9, 3. Then lastly, we have here many to many correspondence. Wherein in many to many correspondence, we have here 4, 2, 4, 3, we have 5, 4, and then we have here 6, 4. That is many to many correspondence. So in relation, we can express that with one to many to one to one, or many to many correspondence. Now, let's have the definition of the function. Okay, so with the definition of the function, let A and B be non-empty sets. A function f from A to B denoted by this, given that the function A to B is a relation between A and B such that For each A is an element of A, for each B is an element of B, such that the ordered pair A comma B is an element of F. In addition, if A and B is an element of F, then and A comma C is an element of F, then it should be B is equal to C. Okay, B should be equal to C. It just means that the functions defined as F from X to Y is a set of ordered pairs of real numbers X comma Y or A comma B, in which not two distinct ordered pairs have the same first number. Okay, so note two distinct ordered pairs have the same first number. Okay, now in graphing the function, uh, in graphing, we can identify if it is a function or not by using the vertical line test. Okay, so in vertical line test, a graph represents a function if and only if no vertical line intersects the graph in more than one point. Again, if no vertical line intersects the graph in more than one point. In addition, if you identify that the given graph is a function, we can also identify if it is a one-to-one function or not by using the horizontal line test. A function is one-to-one if no horizontal line intersects its graph more than once. Okay, so let's try. So given this graph, these two graphs, let's try to identify if it is a function or not using the horizontal line test. Okay, so here, the first one in circle, let's draw a vertical line. So as you observe, we have here 2 points that intersects with the vertical line. Okay, there are 2 points in the graph that intersects to the vertical line. So if that's the case, it violates the idea that the graph can be a function. Okay, so as you remember, by the definition of the vertical line test, the vertical line should only intersect at one point. So in this case, this is not a function. Okay, a circle is not a function. Another example, let's say we have here a parabola. So let's try to use the vertical line test. So as you observe, it only intersects to one point. And then if you draw multiple lines, vertical lines, you will see that there is only one point that will intersect. So if that's the case, we can say that this is a function. Okay, this graph is a function. Now, so given that this is a function, let's try to identify whether it is a one-to-one function or not. Okay, so for us to identify that, we're going to use the horizontal line test. Okay, so let's use the horizontal line test. So we draw a horizontal line. And as you observe, there are 2 points in the graph that intersects to the horizontal line. There are 2 points. So if that's the case, we can say that this is a function but it is not a one-to-one function. Okay, this is not a one-to-one function. Another example. So given that we have here a linear graph, let's try to identify whether it is a function or not. Okay, so if you draw a line, a vertical line here and here, and you draw multiple vertical lines here, as you observe, there are only one. There's only one. There's only one point that will intersect to the vertical line. So if that's the case, this is a function. Okay, now let's use the horizontal line test. So if we observe using the horizontal line test, there's only one point. Okay, there's only one point. If you draw another horizontal line, multiple horizontal lines, there's only one point that will intersect to that horizontal line. If that's the case, we can say that this is a one-to-one function. Okay, this is a one-to-one function. In addition, we have another graph. This one is cubic. So if we're going to use the vertical line test again, it only intersects to one point. So if that's the case, we can say that this is a function. Okay, this is a function. Now, using the horizontal line test, again, it should only have 1 point for us to have a one-to-one function. So in this case, it's still 1 point, okay, that intersects to that horizontal line. Okay, so if that's the case, we can say that this cubic, is a one-to-one function. Okay, this is a one-to-one function.